dashing through the snow in a one-horse open sleigh. Oh, what fun it is to ride in a one-horse open sleigh. Jingle bells, jingle all the way. Oh, what fun it is to ride in a one-horse open sleigh. A day or two ago, I thought I'd take a ride, and soon Miss Fanny Bright was seated by my side. The horse was lean and lank. Misfortune seemed his lot.
Hello there.
He got into a drifted bank and we got upside.
Let me turn down the volume of these Christmas tunes that we have today. I hope the music is not too loud. Okay, hello and welcome to Rapper Live Show. As every Friday, we are here to share with you some useful information, useful tips about 3D printing technology, and yes, some useful things. I am Jay from the RepRapper technical department, and here my colleague Iko from RepRapper e-commerce department. Today we are going to talk about how to use the
3D printer.
FDM 3D printer. Yeah. But before we start, hello there, Merry Christmas, Eric. Yes, thank you. Before we start with the show, my colleague is going to do a brief introduction about our company.
Yes, our company, RepRapper, was founded in 2012 with the objective to produce the high quality practice filament for the 3D printer that was starting popular at the time. Our name, RepRapper, came from a project, movement that MD2 every family could have a affordable 3D printers. So we can print some tools or something else in our home, so we can save some money or something else. So at the beginning, we just have the practice filaments, just like PLA, ABS, and PETG, and some foundation practice filaments. Not only the filaments that we sell on Amazon, but now we only have the resins, just like
we produce a lot of different resins, right?
Yes, just like standard resins and ABS
resins. And water washable. Yeah. Some special resins for dental.
Yes.
For doctors, right?
Yes.
Yes.
So
maybe Christmas Carol. Yes. Okay. And yes, as Eko mentioned, yes, maybe at the beginning the company started producing the filaments, but now yes, we evolve and we produce like a large range of products for 3D printing. And well, we do these live shows every Friday because we want maybe to help you to take advantage of our products and also 3D printing in general. And you know, we have like 6 episodes, right? And maybe the first 3 episodes are about FDM 3D printing. Yes. So we see how to slice, how to use the 3D printer. In the next live show, we will see how to print different printing materials. Then we normally have 2 live shows about LCD printers, resin printers, where we show how to slice and also how to use the resin printer. And the last episode is like open topic one. So in each season we change the topic for the last episode. The last time we discussed, I think we show how to. You can go to our page and you will find there the last episode. Right?
Yes, we talk about
Octolabs. Yes, yes. How to record mesmerizing time-lapse video using Octolabs. Very interesting.
Yes.
Okay, but today we're going to talk about FDM printing. Okay, so our plan is first maybe we are going to take a general look of the different 3D printing technologies available. Then we are going to talk about this kind of technology, the FDM technology. Let me see. Okay. We will see different shapes and different kinds of FDM printers, and after that we will take a look of the common elements of every FDM printer, and yes, at the end of the live show we will show you like the basic operation for one machine like this one, like this Ender 3. So yes, we will start now. And okay, so before diving in this technology, I want to show you the different technologies available, because in fact FDM, I mean 3D printing like includes different technologies that have in common one thing, and the thing is that you build objects by adding material. That's why 3D printing is also called additive manufacturing, and that is in comparison with traditional maybe production methods when you remove, like for example, if you have a piece of wood and you are carving the wood, you are removing material. Or if you have something like some of these things that a mile machine, maybe you put a block of metal there, and a tool is going to remove the material from the block, and that's the way it creates objects. But the 3D printing technology does the same, but adding material, right? So the three technologies, and I'm going to show you now. Let me change here. These are the three common. Let me change maybe this way is better. Yes. These are like the three main technologies in 3D printing: FDM, SLA, and SLS. Okay. FDM is the filament deposition modeling, and maybe I can switch off the camera a moment. Yes, these are the machines we are most used to, because these are the ones using the filament. And as you know, this kind of machine is able to produce this kind of parts. The resolution is not super high, but I think is very good for a lot of works. And these machines work with a plastic filament. This is the material they use, and the parts, the printing process look like this, right? Yes. On the other hand, we have the SLA. The SLA technology works by hardening a liquid, a resin, using some kind of light source, right? So let me go very fast through this one. SLA printers are basically the resin printers, and they have this. The silver, yes, it's good that silver is our silk, PLA silver. The resin printers, at least the domestic one, has this, this aspect, and this is the kind of part we can do with resin. These machines are going to use a liquid, and that the problem of using a liquid is that it's more messy than the filament, right? But normally these printers allow to very high resolution objects, very highly detailed objects. The problem is that maybe they are not as safe and as easy to use as the FDM printers. And the last technology we have is the SLS. And you can see in the picture, this looks more like an industrial machine. In fact, these machines are like super expensive. Maybe you need $60,000 for one of these, $100,000, $200,000. These are more like industrial machines, and these ones use a powder. In fact, you can print almost a lot of different materials, even metals. What this machine does is, yes, they take a powder, for example, the metal powder, and using a laser, a very high energy light source, is going to, it's called sinterization. It's like they are going to melt, the powder in some like very, accurate way, and they are going to build objects like this in the picture. You can see. So these machines allow for super high resolutions, super strong parts. The problem is not only the price, but or the size, but also the parts require some post-processing. So, after printing, you need to remove all the powder, like you can see in the picture, and this powder is not very good for your health, probably. So you need, a setup like this one. Yes, the SLS printer, I think you can see in the pictures now. I cannot tell you about models exactly because I don't work on these machines, but you can see in the picture. It's like a big thing, big machine that you can have in your factory. Okay, so well, yes, we are back.
Yeah.
So that is about general overview of different technologies. Now I want to show you more in detail what the FDM printer is. Okay, and basically this technology is based in a very well-known and common technology, which is the CNC machines. And the CNC machine is basically something that can move a tool in a three-dimensional space. I have a video here of a CNC machine. You can recognize probably this kind of thing. This is called a mile, I think. And you can see the machine has a tool and a axis system that allows you to position the tool very accurately in a three-dimensional space. And depending what is in the in the tool head, you can do different operations. Maybe you can like drill, or you can remove material. So the FDM printer is basically a CNC machine, but it's a three-axis CNC machine. But in the tool head is a Hotend that is going to deposit is going to extrude some plastic material, and that's how it works, basically. So you see, these are the common reverse CNC. Yes, I think that's a very smart way of thinking about it. Okay, this is like the FDM printer, right? So we are going to have a system of three axes. We are going to have an extruder that is going to push the filament, and we are going to have a Hotend, which is the element that is going to heat up the filament so it can melt. And then, very important, also we are going to have a printing surface. A printing surface, which is fundamental because in order to 3D print, we need that the parts are, well, in place, well sticked. Okay. So later I will show you, in this machine exactly where are the axes and everything. Now I'm just going like a little fast about this. Now about the FDM printers, I want to show you that there are different types of 3D printers, of FDM 3D printers, sorry. The first distinction I want to do is talk about the Cartesian and the Delta printers. Probably you have seen this kind of Delta printers in some pictures, I mean, sorry, I need to remove the camera. The Delta printers look like this. I have here, and these machines, the difference is that they use the polar coordinates instead of the Cartesian coordinates. And in fact, these machines they are simpler in a way because they use maybe the structure is simpler than the Cartesian printer, but they are also less intuitive and more difficult to level normally. Maybe now they have the automatic leveling, but normally these machines are not as intuitive and also a lot more difficult to level, but in fact these delta machines are known to be very fast and very accurate. They can like move very fast. I can show you this little video I have here.
Now,
You can see how fast can the movement is.
oh, his thing, the hexapod. I think there's a, discussing it with him on Sunday, I think there's a fundamental, I'd like to say software because I'm not a software guy. What'd she say? Thanks, Ruth. That's a good thing I'm recording our sound here. He's using, oh, ruthless.
Delta printers, and now I'm going to go very fast. The Cartesian printers, right? The Cartesian printers are these ones. We know they have 3 axes and they use like the polar, not polar, Cartesian coordinate system. So that means that we have an X, 3 components, right? X, Y, Z. And all of these are Cartesian. I mean, no matter if the machine, if the FDM, if the printer, sorry, is like boxed shape, like this one, like a closed one, or if it's like this one. All of these are Cartesian printers. The difference between the box one has the advantage of maybe is safer to use because you have a cut. The cut is not going to go inside the machine. That is something that happens. Or maybe if you have kids, it's more difficult maybe to to put the hand inside the machine. Also, these machines have an advantage is that it retains the heat better, and that's very useful when we are trying to print some printing materials like ABS that needs special temperature conditions. These machines, this kind of machine that has like a box shape, is going to keep better the temperature. In comparison, these open printers or filament, I don't know how to call them, they have also their advantages because these machines are simpler, cheaper, right? And also these machines are very good for teaching purposes because you can see all the elements and you can see very easy how the printer is working, and also maybe they are very good for do it yourself because all the elements of the machine of the printer are easily accessible. So if something breaks, you can very easily maybe change the extruder or adjust some gear or something. Say yes. The core is Y. Yes, there are like different setup for the axis, and one of these is core XI, but maybe other day I can prepare. If you are interested about that, we can maybe show the difference about the core XI and the HBot. I think is called the other setup. Okay. So now we already very fast took a look of different technologies available and different FDM printers available. And now what I'm going to do is to use this Ender 3 printer that we have here, and we are going to show you like the elements of every FDM printer. Okay. First element is the axis. We mentioned that this is 3D printing, so we have 3 dimensions, and those 3 dimensions are going to be defined by the 3 axes of the printer, right? So in this, maybe now I need to remove this model. We don't want to break this. In this kind of FDM printer, the three axes are like this. This one is the x-axis. Okay, so this means that the x-axis allows us to place the Hotend, in the x direction, in this direction, horizontal. The y-axis is going to be given by this movement platform here, and this is the y-axis, and then the z-axis is basically this up and down movement that the machine does. So combining the three axes, you can see how we can position the tip of the Hotend, which is the nozzle. We can position in every place of this like region, right? Three-dimensional space that we have here. Maybe we can change to this auxiliary camera just to show you in detail. For example, that the z-axis is this one. We mentioned is this one, right? This one is going to use normally it's going to use this kind of belt. Let me focus the camera. Okay, so the x-axis and the y-axis normally uses this system of belts and gears like this one, right? And this system, I want to mention that it's very important that these belts are tight. So if we are having problems, one of the first things we should do is to ensure that the belts are tight. Okay, and in contrast, the z-axis, instead using the belts, uses this. This is like how is the name? Lead screw. Is like a screw, and the reason why they use different like motion systems is because the z-axis and the y-axis normally when we are printing, these are constantly moving very fast, right? So the belts apparently give us they are better if we want to move something very fast and a lot of time, move something a lot and very fast. But this kind of movement system, this screw, is better. It's probably more accurate than the belt system. But yes, basically the z-axis only needs to move a little during the whole printing process. In fact, it only moves maybe a few millimeters, less than a millimeter, for each layer. Well, I don't know if that was really useful, but it's okay. Let me show you this. This is a stepper motor. This is the kind of motors that our printers are going to use. And these motors have the feature that they can, they can position the board very accurately, and they have a relatively high torque. So they are very suitable, very good for our printers. And it's important to know that normally we are going to have a gear that is installed in the motor, and at least in the new printers, in some of the new printers, this gear is directly like pressed here, so we are not going to have any screw. But in some old printers, and I don't know, in all the old printers, and maybe in some of the new ones, taking count that if we need to ensure that this screw is well adjusted, because if this is not well adjusted, maybe the gear is not going to move at the same pace that the board of the motor. So yes, I think it's important to know. Okay, now next thing, this some people say maybe it's not useful anymore, but I want to mention the nth stop because I think this really maybe helps to understand how the machine works. Okay. So before talking about the end stop, I want to show you. I mean, we mentioned that we have the 3 axes, right? So when we start printing, what the printer needs to is to go to the home position of the 3 axes, and that means that is the position where the x, the y, and the z equals to 0. And that position normally in the Ender 3 is going to be like in this corner. I mean, the 0, 0, 0 position is when the nozzle is in this corner of the surface. Or, I mean, this is the x-axis, so when the x-axis is here, now the x-axis is in the 0 position, and when this one goes here, also maybe you can actually like this is, I don't know if you can hear this. This is the sound of the end stop because it's like a button. So now the y-axis is also in the 0 position, and now we are going to move down the z-axis, and when the z-axis touches this end stop here, and now I'm going to show you how maybe you can show this end stop. Ah, yes. So you see when the okay, now when the axis touches the end stop, that means that the axis reaches the 0 position. So you can see now how basically the nozzle is where we set it is the home position, is in this corner. So to define where is the 0 position of each axis, the machine, the printer is going to have these end stops. Some of the modern printers, they don't use the end stop, but anyway, the end stop is always going to exist. Maybe it doesn't exist like in the shape of a button, like this one, but maybe it's going to be like in the firmware, or the printer is going to use another way. But I think this is the classic one and is the easiest to understand. So basically, we place one of these in the 0 position of its axis, and when the printer touches this one, yes, it's going to send a signal to the firmware, and the printer knows that the axis reaches the 0 position. So end stops, important, especially important maybe if you, for example, change the shape of the printer. Maybe you want to add, a bigger x-axis, or maybe you want to change the surface and put something thicker. You need to take in account this one, and maybe you need to move. Okay. So both things we talk at this point, I mean the axis and the end stops, this is something common to all the FDM, to a lot of different machines, not only 3D printers, right? Now we are going to start seeing something that is specific for the 3D printer, and is the Hotend. So the Hotend is, as we know, the element of the 3D printer that is going to heat up the printing material. Normally it's going to be a plastic, and yes, it's going to heat up because in order to be extruded, the plastic needs to be like melted, like a liquid, right? And the Hotend, I can show you. What do we have here? Hotend anatomy. Yes, this is. I mean, not the hot ends look the same, but all of them has like the same structure or like similar design in some way. So normally all the hot ends are going to be divided, like they have the cold part and the hot part, okay? And you can see we are using, all of them are going to have this kind of heat sink, because in fact for this to work properly, one part of the hot end needs to be cold and other needs to be very hot. But well, let me show you with this one I have here. So this is the A3D hot end, and let me focus the camera. Give me a second.
Yes.
Okay. This is A3D hot end, and what can we see? Okay, of course this is the nozzle. This is like where the filament, where the metal filament is going to come out through this little hole, and here is where the cold filament is going to go in the hot end, and you can see how we have two very clearly differentiated parts. We have this part, which is the cold area, and this part, which is the hot area, and in between them we have this. It's called a heat break, and the heat break is, the purpose of the heat break is precisely, to create a difference in temperature between this part and this part. Okay. So the thing is, we want that only the filament that is near the nozzle is like in a liquid state, because if all the filament that is inside the hot end, if all the filament was liquid, very hot, maybe when we push filament through here, it will like flow back, and maybe we would have problems in order to make the retraction movement. So for this to work properly, we want that this filament is cold, and just in this area is the hot filament, the melted filament. This part is called the heatsink, and you can see it has this shape, so it can cool down properly. And this part is called the heater block. This is a block, heater block. In the heater block, we are going to have the nozzle. The nozzle that, as you probably know, depending, we can use different kind of nozzle sizes, different size of nozzle, and depending of the diameter of this small hole, we can have like depending on the size of this hole, we can have like better quality printing, or maybe we can print faster. So we can choose the nozzle that fits better our print job. And also now I can show you every hot end is going to have two electric elements. One is this one is the heater cartridge. This one basically is going to heat up. This is going to produce heat, and the other one is going to measure the heat, like read the temperature of this heater block. So using these two elements is how the printer can heat up this to the temperature we want to use. This one is going to give us the heat, and this one is going to measure the heat. Yes, and this is about the hot end, This model is it was very popular in the past. Now it's still popular, but now because most of a lot of people is buying this kind of Ender 3 printer. They produce, Ender Reality produces their own Hotends. Yes, hair cartridge and thermistor. That's right. Yes. Okay. Next thing. What is this? What do you want?
Change the screen.
Change the screen. Yes. Now we can talk very fast about the extruder, which is another element that is specific to 3D printers. The extruder is the device that is going to push the filament. The filament normally, yes. And in the past show we had here the stock Ender 3 extruder, but now we install these double gear extruders, and I'm very happy with them, especially because this is very cheap. You know how much we paid for this? You know, one of the good things of China is here we can buy quality products very, very cheap. So maybe this one was only maybe like $3 or something like that.
Yes.
And I think it has almost the same functionality than the original one that is maybe $80. But in theory, the original one is probably has some more quality. But this one does the job. This one does the job. In fact, we can show you. We printed this kind of model, very detailed model with a lot of retraction, and we print all of this using this $3 extruder. And the problem of the extruder is nice, but we cannot really see inside. So I think it's better if I show you in the pictures. Okay, so here maybe you can see more clear how is the mechanism of the extruder, right? So we are going to have like a lever and a gear, a drive gear, and some mechanism that is going to push the filament against the drive gear. The drive gear is going to have some teeth, and yes, the teeth are going like to grab the filament and push it down. Basically, we have two kinds of extruders, the direct and the Bowden. The Bowden extruder, here we can see the difference. The Bowden extruder is going to have a tube, and it is going to push the filament through a tube, and the tube is going to conduct the filament to the nozzle, to the hot end, sorry. In comparison, the direct extruders are mounted directly on the hot end, like in this picture. Yes, in fact, Eric, I feel like the same. I don't know. Well, I don't know. I mean, I'm pretty sure. Why Creality uses the Bowden extruder? Well, it's probably because it's cheaper, right? But also, I think it's easier to repair probably the Bowden extruder, because when you have, in my experience at least, if you have here the direct extruder and maybe you need to unclog the nozzle, something like that, maybe you need to disassemble more, and also maybe until disassembling you need to level again, because you are going to maybe lose calibration for the bed. And I think one of the good things of these Bowden extruders is that yes, you have two clearly separate mechanisms, two different elements, so you can repair the extruder, you can maybe fix something you have here, and you are not touching the nozzle. So in that regard, that is an advantage. But of course, the printing quality is better for the direct extruders, especially yes when it comes to the retraction movement. And also, as you know, for filaments like the flexible filaments, with the Bowden extruder, it's very difficult to print with them for flexible filaments, you definitely want to install a direct extruder. I hope in the future we see more 3D printers with the direct extruder. So yes, I'm with you in that regard. Okay, in the picture here you can see what a direct extruder is, right? So we have the extruder and the hotend, and they are part of the same thing. What I want to mention about the extruder, I think is important. You can see we have the extruder here has a screw, and in the case of the double gear extruder I have here, you can see when we put this, you know, we adjust by like screwing in this screw, and this is going to allow us to regulate, to adjust the pressure that the dry gear is doing on the filament. And we need to be careful, because if the pressure is not enough, maybe the filament is not going to be pushed correctly, and we are going to lose steps in the extrusion. But if we tight this too tight, we can destroy the filament. Maybe we will have filament grinding, and this is especially important to print the flexible filaments, because if this needs to be very well adjusted to print flexible filaments. Okay, and now printing surface. Printing surface, very, very important, right?
Yeah, I think you want to mention about this.
In fact, if without a proper printing surface, we cannot print. We need a printing surface that is able to, to keep in place our parts during the whole print job. And well, that has some science, in fact. We definitely want that the print stays in place, right? So we need two conditions basically to achieve that. First, the distance between the nozzle and the surface needs to be the right one. So it's very important that the bed is well leveled, and that through the whole area of the surface, the distance from the nozzle to the bed needs to be the same, and also needs to be the exact that allows for the filament to stick. The other condition is that the printing surface needs to have some adherence, because there are some surface there that even if we put the nozzle perfectly leveled against the surface, if the surface doesn't have enough adhesion, the filament is not going to stick. So about the adhesion, that's why the 3D printers nowadays, most of them use the heated bed, because if we heat up the surface, normally it's easier for the filament to get correctly stuck to the surface. And also that's why we have different kind of surfaces. This one is new. Is something new I have here. Well, it's not new. It's new only for me, because we buy this recently. But you can see this thing has a special texture here. So in theory, this is designed in a way that this texture, this material, is very, very good in order to stick the filament here. There are different kind of surfaces. We can use the most classic one is just the polypintite, the crystal tempered glass. That's when I started printing. We used to buy the IKEA mirror, and we printed on a mirror. Then they started to be very popular. Some surfaces like the built-tack surface, which is like a black plastic surface. That's like the same that Ender 3 and most of this kind of 3D printers use now, like a black plastic thing. And recently, well, not recently, but from some years, this kind of surface is also becoming popular. This is called the PE surface, and I don't love it, but it's okay. It's okay. Whatever suits you guys is the best for you. I mean, when it comes to printing surface, I think each user has different opinions. Let me know in the comments what is your favorite surface. Okay, and finally, some things maybe are not that important, but we can mention. Almost every printer is going to have like a control panel. Maybe we can switch off this one. Yeah, the control panel, maybe it's like this, maybe it's like LCD, I mean like touchscreen. Maybe you don't have one and you are meant to control the printer using the computer, but normally you are going to have some way to, you know, start the print, etc. Every printer is going to have some electronic circuit board. In the case of the Ender 3 is, yes, you can see, you can follow the cable, yes. So the cable goes in the printer and there is a box there, and in that box there is one of those circuit boards. Of course, power supply. So yeah, this runs on electricity, right? So we need some kind of power supply. Let me mention that if your power supply breaks, you can use your computer power supply. Normally is compatible with this. It's like very similar. And the spool holder, right? Spool holder is very important. I mean, without the spool holder, we cannot print. Probably, especially we cannot print large prints. This one is okay, especially for this kind of spools. But maybe if you want to use the 3 kilogram spool, there are different options there. Okay. So that's about what we wanted to talk about like the elements of the 3D printer, of the FDM 3D printer, right? Mm-hmm. And now, to finish the live show, what we do is, yes, of course, I know, in fact, I know most of our viewers are very advanced, and probably everything that we are telling here, maybe you already know. So I don't know if it's really useful. I hope some of you guys can teach something from us. But anyway, thank you very much for your support, Eric. Okay, and to finish this, we promised that we were going to show you how to use the 3D printer, and that's what we are going to do. So, I mean, it's a complex thing because first, of course, we need to slice the file and that kind of things. But we are going to assume that the file is already sliced. In fact, in our previous live show, we already showed you how to slice. So once we have the G-code file ready to be printed, there are 3 conditions to be met in order to print. Wait, a little.
Okay.
Please. So, if we want to print, we need 3 things. First thing is that the filament needs to be loaded in the printer, and needs to be like, you know, the filament in the tip of the nozzle, and the nozzle needs to be unobstructed, and the extruder is well adjusted. So I mean, the filament, the material is ready to be extruded. That's condition 1. Condition B is that the bed needs to be well leveled, and condition C is that the program, the G-code file, is ready, is loaded in our SD card, and is ready to start printing. So that's the three things. First, we are going to show you how to load and unload the filament. Okay. How are we going to do that? Okay, so now is when we maybe put the printer like I want to put the printer here, so we can show you more in detail how we do. So first of all, you can see now we have some old filament here. So the first thing we need to do is to load the new filament into the printer. Okay. Good. How we do that? Always, I mean, when we change the filament, load new filament, we always want the hotend to be heated to the printing temperature, because if we want to extract the filament, we want that the filament is melted. If we try to extract the filament but the printer is cold, normally like the filament, the plastic is going to be like stuck there. So if we try to extract the filament, maybe we will break something. So first step, always heat up the machine. Heat up the machine. We are working with PLA, so we are going to use 190 degrees, for example, something like that. And now I want to, yes. You can see, now we are heating this, and you can take a look. Okay, so maybe you can help me with this one. Oh, thank you. Okay, it's almost ready. So, some of these machines are going to have like automatic loading and unloading, but I don't like that. I prefer to do it manually. So what I do is I'm going to release the tension in the extruder. In this case, we just remove this and open. So in other extruders, we need to push like the lever in order to release the tension, but this one is easier, I think. And now, my recommendation is don't try to directly extract the filament, because sometimes the tip of the filament here is going to be thicker. So my trick is to push a little, you know, and when we see that the filament is coming out the nozzle, is when we can, you know, remove. We can extract the filament, no problem. I think that's the best way to do it. And now we are going to proceed to insert a new filament. I want to show you, you can see in this spool, when the filament is not loaded, the filament, we always place the tip of the filament. We always place it in the filament holder holes here. And this is because, you know, this is to avoid a very annoying problem, is that if we don't fix the tip of the filament, if we release it, maybe the tip of the filament will, you know, go like under some of these spires, under some of the filament in the spool, and we will create a knot, and the knot, a tangle or a knot that is going to ruin our print job. So remember, guys, always, when you are not using the filament, put the tip of the filament here. Okay, this is the way to do it. So now, yes, it's super easy. You know, just we need to introduce the filament here. The problem, not the problem, but sometimes, because the filament has some like natural curve, if we try to introduce directly, we will, you know, it will like crash with something inside, and it can be difficult. So the best way is to try to make the tip of the filament a little more straight, like this, and now we can to introduce the filament. If we are having a lot of problems, we need to, maybe we can even use a knife, a little knife, to make the tip of the filament look like a, like an arrow. Because sometimes in some extruders it can be difficult, but I think when we have some experience, it's easy to do. Okay, now, so we put this inside, and you can see now it's going very easy. And we introduce manually, and when it reaches the hot end, we can feel that now we reach like the end of the bottom tube, and in fact we can see. Maybe you can now focus this area. You can see now we can push the filament manually, and basically we can push a little filament until it starts coming of the color of the new filament. So in this position now the filament is loaded and it's ready to be extruded, basically. Let me say that maybe now we are we had PLA loaded in the 3D printer, and we are using new PLA. So the temperature is the same, but for example, if we had ABS loaded in the printer and we are introducing PLA, it's better to heat up the printer to the printing temperature of the ABS, because that way we can remove all the rest of ABS that is in the extruder. Okay, now this is okay. We can close the extruder. We put this here, and we adjust this. And yes, it's difficult to explain exactly how this needs to be tightened, but well, I hope this is something you will get with some experience. Okay, now let me change this. We can change the camera again. Yes, because now what I do normally is change the camera, the angle of the camera a little, like here, because I want to show you how to do the next step, which is how to level this bed. How to level the bed. Okay. So basically, you see, we are going to have these knobs, and these knobs are going to allow us to place this like up and down. And okay, there are different techniques to level the bed, but I will show you the one I use and I like. I call it like eyeballing the leveling. No, seriously, let me show you. Let me remove this. The thing is, we don't want that the nozzle, the filament is coming out the nozzle when we do the bed leveling, because if we have rest of filament in the tip of the nozzle, we don't, maybe we cannot see clearly if the, oh, I need the tool. I will remove just using my hands, you know. Don't do this in your home. Okay. Okay. So what I do is first use the option to move all the axes to the home position. Homing. The homing routine. Okay. Now, oh, maybe I'm going to change a little the camera. So maybe we can see the nozzle clearly. Maybe. Well, you can see the problem we have is the chroma key. So maybe I will remove the chroma key so it doesn't, the background. The background is very nice, but it's giving us some problems. Main camera, filters, chroma key. Okay, yes. Forget about the Christmas background for a second. So after doing the homing, the problem is that now if I want to move manually the axis, I cannot, because the motors are receiving power. So I need to go here in the panel and tell to disconnect the motors, and now I can move this. So basically you need to ensure that in the 0 position the tip of the nozzle is just touching the printing surface. For me, I mean you can, maybe in the camera it's difficult to see, but most of the time you can clearly see if the nozzle is touching or not. Maybe here, this angle is better. Okay. So you can see how when I move this one, the surface goes up and down. So you can use your eyes, or you can use like the paper sheet. What the people normally does is to put a paper sheet between the nozzle and the surface, and you adjust this knob until you feel that the paper is just like touching the nozzle and the surface. So the idea is that, for example, now is the nozzle is too close to the surface, because I cannot pass the paper through the nozzle. The right distance is that allows for the paper to go through the under the nozzle, but we need to feel that there is some friction there. I think this is a little difficult to explain, so for me normally it's easier to manually to use my eyes to see when the nozzle is touching the surface. Maybe like this. No, now we can adjust a little. This one you can see. And also in this corner the idea is that in this operation we are only like doing a first adjustment of the nozzle, of the distance. And when we finish, we can run a bed leveling program that is going to help us with the final calibration. Oh, like this. Oh, what is this? This is the bed level. Okay, now. Oh, but I don't know, we have some problem here. I see some strange reading from the thermistor. Ah, okay. Yes. In fact, for this base surface, we need to use maybe like this, 70 degrees. And now this, when the printer tries to print this bed level in like G-code, we can do the final adjustment, you know, like live adjust the leveling. But anyway, let me see. I think maybe this part of the show we can prepare better for the next show, because maybe it was a little slow, you know, and I don't know if it was very clear how to do the leveling finally. It's about to start. Oh, okay. I can show you here. So you see the bed leveling. This diagram you can see like three different like distances between the nozzle and the bed. So in the upper part you can see if the distance is too, you know, if it's too far, maybe the filament is not going to stick well, and if it's too close, maybe the filament cannot come out the nozzle because it's too. Okay. Okay, let me show you the camera again. So this bed leveling program is going to print a big flat part, and it's going to allow us to check the right leveling. You can see, for example, here the filament is detaching. This is because this part is not well leveled. So what I do is, you know, I can adjust. You can adjust.
Oh, we need to clean the nozzle
Yes.
first.
Now we have the problem that we need a way to remove the filament from the nozzle. You have some too? Ah, yes, good.
Can you stop it?
Yes. Okay. Normally this is better done with some pliers, you know. Oh my god. Maybe. What the?
We can stop it first.
Okay, maybe it's better if we start again, because you can see we have a mess here of filament. Yes, it's you know, the problems of doing the live streaming. Oh well, now we have. Okay, it's okay. I think we are going to you know, maybe, you know, we failed with this leveling today. Later we'll try to fix it, because apparently our printer. Maybe you can focus the camera again. Thank you. Our printer wants to ruin our Christmas live show. So, where's the pen camera? Don't worry, I have this thing again, the chroma key. And the background video, yes, good. Yeah, so sorry guys, I don't know, we didn't have very well prepared the leveling of the printer. You can see it can be challenging even for experienced users like us. But don't worry, later we will level the machine, of course, after the live show. And yes, in fact, I think this live show was a little longer than expected, so probably you want to go to the bed, and we can close, we can end now. Anyway, let me get rid of this. What we want to do is, right, give you, you know, thank you. Thank you for watching our live show, and yes, for your support.
How you can learn something from this live show. Okay.
Probably not how to level the bed today, but some of the other things we teach probably are more useful.
Yes.
And anyway, yes, want to wish you Merry Christmas. We were going to sing something, but
No.
I think my friend Echo feels a little cringe about it, so we are not going to sing nothing today. But we have the desktop audio, this nice Christmas song. So we will leave you with the Christmas song and wish you Merry Christmas, and see you in the next episode. It will be the next year, right?
Next year, yes.
It will be the next year, because in fact the next year, yes, next year. So see you the next year, and Merry Christmas. Bye bye.
Bye bye.